In this video, I'm going to introduce complex numbers. Now, complex numbers will allow us to talk about situations that have the square root of a radicand which happens to be negative. The first thing we're going to do is make a definition. If we have the square root of some negative value, and we're assuming here that n is greater than 0, then we're going to replace that with a product. The first factor is going to be the letter I, and the second factor is going to be the square root of the opposite of our original radicand. Once we've made this replacement, we're able to move forward with the square root part because our radicand is now positive. So, for example, if I have the square root of -4, I can replace that with I times the square root of 4, and of course the square root of 4 is 2, and we could leave it like this, but people prefer using the commutative property, since this is a product, to rewrite the factors as 2i. Now, it's common for people to say, well, you just made up something here. And although that's true, the number 7 is also something we just made up. So it's not really so much an issue of, is this something that we can do? It's, once we've done it, does it lead to contradictions? And it turns out it doesn't, but it also turns out that it's more subtle than you might suspect. So again, the idea is we're going to begin with the square root of a radicand which itself is negative, such as this, and then we're going to replace that with a product, I times the square root, where the radicand is now its opposite, and then we simplify the square root, and we often rearrange the factors. A special case of this is that we let n be a 1. In that case, we'd start with the square root of -1, which we could replace with I times square root of 1. Square root of 1 is 1, and the product of I and 1 can be replaced by just I. So I is the square root of -1. This implies a second part to our definition, that is that I squared equals -1 itself. As soon as we let I into our number system, we have what are called the complex numbers. These are written in the form A plus BI, where A and B are real numbers and I is the imaginary unit. And again, we think of I as square root of -1. So complex numbers are written as a sum. For instance, this is a complex number. It's 6 plus 1i. So in this case, A is 6 and B is 1, but we don't write the 1 because 1 times I is usually just written as I. Here's another case, and as you might suspect, we're going to think of subtraction as adding the opposite. And so in this case, A is 5, and B is going to be -3. Notice that when B is a 0, we only have A, since if B is 0, then this product is 0, and A plus 0 can be replaced by just A. So when B is 0, we have our real numbers. That means the real numbers are a subset of the complex numbers. For instance, the number 8 can be written as 8 plus 0i if you want to write it as a complex number. When A is 0, we have a pure imaginary number. For instance, 0 plus 9i would just be 9i. One way to visualize the complex numbers is to think in terms of two axes. One axis is just the real numbers. This is the real number line that you're used to. And the other is the imaginary number line. And this runs perpendicular to the real number line. So this is going to be our real number axis. This is going to be our imaginary number axis. And if we were interested in a number like 3 plus 2i, we would go 3 units on the real axis and then move up 2 units on the imaginary axis. If we wanted to find 1 minus 4i, for instance, we'd move 1 unit in the real axis and we'd go down 4 units on the imaginary axis. And one more example, if we had negative 3 plus 3.5i, we'd first move to the left 3 units, and then we would move up 3.5 units. Well, that concludes this video where I've introduced the complex numbers.